Welcome, girls, to the subject of productions and operations management. We are dealing with unit number 4, that is process selection. This is the concluding part, that is part 5. In this unit, we have dealt with many concepts related to process, like what is process, different functions of process, two aspects of process, decisional areas, factors influencing. In the previous lecture, we have also seen the process types of process strategies, right? Again, there are two aspects, that is make or buy decisions or factors affecting, that we have checked out. We have seen the major strategies related to it in the sense process focused, product focused and repetitive in nature, and we have also checked out with the comparison of the strategies. The major area that we are dealing is said to be the major process decisions. Major process decisions include 5 major processes, out of which the decision that is crucial and that is required by the manufacturer to be taken properly is the process choice. Though there are 5 major decisions that can be undertaken by the manufacturer, they are said to be the process choices, it can be the vertical integration, it can be the resource flexibility, it can be customer involvement or capital intensity. Means these are the 5 major areas or 5 major decisions that are generally taken up by the manufacturer. But out of them, what is important and what your syllabus is covered with is about the major processes, right? And we have been learning major processes since the previous lecture. We have already done with the job process, and we have job shop, and we are done with the batch process. In this session, we'll be completing the 3 more types of processes. So if you can see it on the slide there are 5 major processes or 5 alternatives available to the manufacturer, like job shop, batch process, assembly process or assembly line. It can be repetitive also, it can be named as repetitive also, modular, right? Or the 4th one is continuous process, and the 5th one is the project process. As I told you in the previous lecture, we have already learnt about job shop and the batch process. In today's session, we'll be learning more 3 processes known as assembly line, the continuous process and the project process. Every process we are going to learn it in quite a detail, right? So let us begin with the assembly line here. It is also known as repetitive or modular. Now what we are doing, you should be clear about this, that when a manufacturer wants to manufacture something or some kind of product, there are number of ways to produce is available to him. That means many options are available, that if he wants to produce say product A, then it can be produced by various means or it can be produced by various different methods, but he has to select the best methods depending upon the factors that affects the organization, and those factors are considered first, and then the process selection is being made. When we are talking about the process selection can be of number of types or from number of types. That means 5 major areas are available, or we can say 5 major types are there, and out of them the best can be selected. Out of this, we have already checked out with job shop, which is more like a customized ordered goods make to order, right? We have seen the batch process, that means small amount of quantity or small quantity of products are produced. When you want to have small quantity of products with high variety, then at that time we go for batch process. The batch process has the characteristic which is very say unique in nature, is that once the process starts in batch production, then only once that process is complete, one batch gets over, only then the next can be produced, and that's the characterization or the basic character trait of the batch process. Now we are going to learn about assembly line. Now what is this assembly line? Assembly line is not a new point for you. Assembling means getting it together, right? Means when you want to combine something, we often use the word assemble, and here we are using the same meaning, and it is self-explanatory also. So let us try to see this assembly line in detail. if the production of the separate parts moving from, it is like production of the separate parts moving from one to another workstation at a controlled rates. That means it is such a kind of process in which the subcomponents keep on moving from one workstation to the another, and at a point of time they are assembled together. It follows a particular sequence, means a sequence is followed, and accordingly the product or the components get assembled, right? This is used when higher volumes of more standardized goods and services are needed. Very important is this area. When you want to have high volumes, that means you want to produce something in a large quantity. They are more or less standardized in nature. That means they cannot be differentiated from one another. They are more or less the same. At that time, what can be done is you can use this type of assembly line, right? Products produced include automobiles. Now what type of products generally come up here? Before that, it is a point there that this type of process is characterized by slight flexibility in the equipments and generally low labor skills. You don't need the skill labor here. You don't need a very say flexible way of process, which was basically required in job shop and maybe to an extent in the batch process, right? Here you can have a slight flexibility of the equipments and you can carry out with the process very easily, right? And because it's just the assembling of the parts, just getting it together in form of a product, you don't need a skilled labor also. So low skill labor is required. Product produced includes, what type of products generally are produced under this assembly line? Then it may be the automobile products, it may be home appliances, television, computers, toys, etc., which has got the production in such a manner that the whole product is segmented or it is fragmented into different parts and components. These different parts and components are produced somewhere else and they are brought together at the assembly line, and then the wholesome product is getting produced there. That is what is the crux of the assembly line, right? Repetitive process is also referred to as line process, as it includes production line and assembly line in the mass production. That means when you want to have high volume of goods, as I said earlier also, and they are highly standardized, then this type of assembly line can be used for mass production, where subcomponents can be produced differently and you just need to assemble it. Means you want to get it together to form the wholesome product. Resources are organized around the product or services, and the materials move in a line flow. That means the flow of the product is very unique and in sequence, right? One operation to the next according to the fixed sequence with the little work in process. Inventory, because whatever number of products you need to produce, for that whatever the components are required are available, and there is hardly any chance of having the high inventory getting piled up, because whatever the number of product you require to produce, the same amount of subcomponents may then be produced accordingly, right? So it is about the assembly line. When we are talking about the characteristics of assembly line, I have been telling you since the previous lecture that all these types of processes that we are learning, they have got subparts. Like we'll be dealing with a part would be, or we are introducing ourselves generally to the process. Then the parts starts. That means A would be the characteristics of the process, B would be the benefits of the process, and C would be generally the disadvantages that can be there of using this process. So in all, what we are trying to say is we get the overall idea about the process and how the manufacturer takes the decision related to process can be very well known. That is why here we are learning the characteristics. Now how this assembly line or maybe repetitive process is being characterized. Number one, it is alternative method of mass production. When you want to have some mass production done, you can go with the product line also, product process also, means one by one the product gets from the raw materials, it gets converted into semi-finished, and it gets more polished at the further stage, and then at the end you may have the finished product. That is one way of producing mass in mass, right? And this is assembly line is one of the variation of the mass production, alternative method of the mass production, wherein all the subcomponents are being gathered at one place, and then the it undergoes the production or maybe getting it together or maybe the assembly, right? It is used for giant machines, equipments, vehicles which requires several parts to be assembled. It can be used for giant machines, for the equipments or maybe the vehicles also. It is effectively worked out with the line balancing which helps to minimize idle time and bottlenecks. There are no idle times available, no bottlenecks can be there, line balancing is done, and so whatever components you get there, you assemble it and you bring it to the one wholesome product. It reduces the operators because no skilled labor are required here, and operations can be reduced also, and there can be little piling of the inventories, almost no piling of the inventory is required, and it has the production process, production planning and control, which is of complex nature as compared to any other types, because so many, suppose if you want to produce product A, there may be 5 components that you may be requiring it, right? 1 2 3 4 5, and unless these 5 production parts are there or components are there, you will not be able to produce product A. So in that sense, it may be a complex production planning and controlling system of the mass production, right? Now if we move on to the benefits, then benefits can be seen right here. It runs smoothly even when there is complex mass production, though in the last point itself we have discussed that there is a complex planning, but in that sense, in this situation also it can run very smoothly, because if the components are ready, then it's only about the assembling of this process or products or components that comes up here in this process, right? It reduces the work in process inventories, no inventories are required, whatever comes up you bring it to one product. It helps to reduce the bottlenecks as well as the rushes in the production, means none of the situation arises, nor there is any kind of rush of the subcomponents, or there cannot be like problem of bottlenecks, which tells us about the congestion in the inputs and the outputs, or maybe in the flow of inputs and outputs, they are not getting congested anywhere, right? It facilitates the uses of in-house part and components, means whatever the components or in-house production of the components you are doing, you can facilitate it very well. Some part may be produced at one corner of the factory, and the other one at the other one, and in the end what you are getting is you are assembling it to the whole product. So it facilitates this kind of in-house component manufacturing. Idle machine and labor time can be reduced because none of the people would be free there. If the parts are ready, few people would be working with the subcomponents and the other ones may be dealing with the assembling. So hardly there is any idle time, or that is machine time or labor time, that is available. It ensures quality control, because whatever subcomponents you produce, you are inspecting it at right there. So there are hardly any chances that the whole product getting of the lower quality. Automation in the material handling can also be done. That means conveyor belts and rollers can be used for getting the goods transferred from one place to the another, or maybe from one machine to the another machine. So conveyor belts and rollers are the automated machines or equipments that is beneficial to the assembly process. Here we are dealing with the grey part of the assembly process, that means the limitations or disadvantages. It is in a very complex plant layout, right? So if the non-technical person goes there to work, it becomes difficult for him to work, because the plant layout is very complex, many subcomponents, more the number of components rather, more would be the complex plant layout, right? The production planning and controlling obviously becomes difficult and complex. There can be interruptions created. If one machine is not working in the assembly line, then the whole process can be interrupted, it cannot be carried out further. Due to tight balancing line, automated material handling, the process becomes inflexible also. There are hardly any chances of flexibility, because everything is tight and balanced. Everything we are using it in a perfect module. So what happens is flexibility is not available. Again, the specialized supervision is not possible, because whatever components comes from its workstation, they are being inspected there, and at the time of assembly you cannot have the specialized kind of supervision done. So at times the quality may suffer, or maybe there may be a chance of variances in the production. Next comes up is each workstation requires more inspection point. I just told you, so if 5 production of subcomponents are there, that means at 5 workstations you may require 5 different supervisors who may be inspecting the whole process of producing the in-house subcomponent. So these are the disadvantages, but whatsoever it may be, it is highly used for the assembling of the automated say machines, or maybe the automobile in the automobile factories, or maybe in the toys factory. This is the most suitable process, that is said to be assembly process. All right, we are moving to the next one, that is said to be the fourth one, continuous process. Now this is used when very high standardized products and high volumes of goods are to be produced. High standardized means no flexibility, no variance, no varieties are possible. High volume means the demand is very high of the goods, and that is why bulk production is there. So these systems have almost no variety, as I told you, and equipment flexibility is also not available. A continuous process is extreme end of high volume, standardized products and rigid line flows. See, batch was intermittent. There were breaks, right? Though we were producing volume of goods. As far as job shop is concerned, minimum say volume is required, high customization is required, so it cannot be taken up as the continuous process. Whereas this continuous process is such wherein it is the extreme end. Now beyond continuous process, there cannot be any option available to the manufacturer to produce high volume standardized product and in a say a rigid line of flows, right, or rigid line flows. That means the continuous process is the ultimate means to achieve high volume of production. The process often is capital intensive because many equipments and machineries are required. It operates round the clock, and that is why we call it continuous, right? Using all the equipments and all the facilities are being utilized to its best, and you don't have the shutdowns there because it is very expensive. For example, the products made in the continuous process includes petroleum products, steel, sugar, cement, paper, flour, fertilizers, etc., and these are made under this continuous process, where the process goes on round the clock. Almost 100% of the capacity utilization of the equipment is there. As I told you earlier also, batch production is described as intermittent production and is characterized by irregularity, and here the continuous process is the process in which there are no irregularities, no chance of irregularities, and the flow is on a continuous basis. Flow production, it is known as flow production as well. Flow production is therefore a continuous process of the parts and sub-assemblies passing from one stage to the another until its completion. It keeps on producing the parts, it keeps on moving the part from one machine to the another one until it is ready as finished goods. Units are worked upon in each operation and then passed straight on to the next work stage without waiting for the batch to be completed, like we did in the batch production. If the whole batch gets completed, only then the next batch can be taken up. Here you don't need to wait, it's on a continuous basis. One by one the product is getting produced, and that is why we can have high volume of goods there. To make sure that the production line can work smoothly, each operation must be of the standardized length, and there should be no movement or leakages from the line. That is, the hold up to the work in progress should not be there. Continuous process itself has a characteristic that the flow of the work has to be smooth enough and on a continuous basis. If there are any kind of hold ups or any kind of delays, then it may be very injurious. So for the flow production to be successful, there needs to be continuity of the demand. If the demand varies, this would lead to constant overstocking of the finished goods, and then you will have to have the clearance sales for it. So it is very important that there should be continuity of demand. Depending upon the demand, then the production is carried out. Achieving a smooth flow of production requires considerable pre-production planning. Naturally, you have to ensure the availability of the raw materials, and you have to have the delivered just in time products should be there, sufficient labor should be there, so that we are not missing any point, and only then the continuous process can be carried out without any hurdle. We are moving towards the characteristics. It is most suitable for the the production of mass production, or that means less variety of the product, where you have standardized production is there. This is the most obvious production process. Next comes up is line layout is used. One by one the processes are set, and you can carry out the product from one stage to the another. The next one is the installed production capacity is fixed and there are no chances of flexibility. Next is material handling can be automated. That means conveyor belts or maybe rollers may also be used. Duplicated machines may be required because there may be number of lines that may be working at a time, right? Suppose a product may be produced by number 1 line also, number 2 also, number 3 also, and likewise. That means there may be so many duplicated machines which may be required for each line. The production depends on demand. I told you earlier also, these are such products which are highly consumed, and only then this production system is affordable. In case of changes in the demand structure or maybe market structure, like if there is any fluctuation in the demand, say if the demand falls, then eventually what happens is the stock gets piled up, and then it is very difficult to cope up with the finished products. Then you have to bring it to the market for the sale at lower rate maybe, right? So this may be the scenario. We move on to the benefits of the continuous product. Speedy production because straight line is there. Investment in work in process is less, but you have to make heavy investment in the fixed items, right? The production cycle is fast enough. Automation of the material handling can be done. The control becomes easy because at each stage you know whatever is happening, that's a straight line kind of production done. As there is line production, faults can be easily detected. At each stage you can make out that if any prior errors are there, right? So that can be detected very easily. As jobs are standardized, the supervision can be reduced because standardized ek dharu kaam monotonous work chale chhe, so there are hardly any chances of supervision. Once it is set, it can be avoided for the supervision, right? Production planning and scheduling is comparatively simple because standardized goods are produced. There are no chances, as we said, of any kind of flexibility or variance or any changes, so it can be carried out like that. Moving on to the disadvantages of continuous process, it is as I told you, heavy machines are required. You need to have lot many equipments in that case. So what happens is initial capital investment may be very high when you are going for continuous process. Again, the maintenance cost is very high because continuously you will have to maintain all the machines and equipments, because any breakdown in one machine may interrupt the whole process and that cannot be afforded. That is why it is very important to have the maintenance there, and for that you may have to pay heavy prices for it. As it is highly standardized, flexibility in the sense of change in output is difficult. Naturally, it is highly standardized in nature, so what happens is flexibility is not available and output may not be may always be standardized, right? Again, the disadvantages results in high fixed cost and low variable cost because already the fixed machines and investment and facilities have higher investment in it, and so what happens is that investment is very high, fixed cost investment is high, and the variable cost may be comparatively low. Machines and equipments may get outdated very easily. See, you may be investing too much of money on the fixed installations of the machines, but if the new technology comes up, then the installation of these machines may create a kind of say dead investment, or the obsolescence of these machines is quite possible, because if new technological advancement comes up, then every now and then we cannot make changes in the machines or the usage of equipments. That is why it gets outdated easily if the technology advances fast. There is a line production, so breakdown we have already studied. Breakdown in one machine may lead to the interruption of the whole process there, right? Because it is monotonous in nature. Monotonous means ek daru kaam chalto hai, ek daru production chale chhe. It affects the employees' morale at some point of time, because there is no creativity, there is no flexibility. It goes on mechanically, and so what happens is at times it may affect adversely to the employees' morale, right? They don't feel anything new every day to come for in the production, and that is why it may affect the morale adversely at times. Next comes up is the last process and the last part of your these unit, right? From the next unit we shall be starting with unit number 5, that is the last unit of your syllabus that we shall be initiating with. Now come to the project process. It is the distinctive time consuming activities performed in a particular sequence. Very important is the sequence is followed. Every product is a project, right? It is characterized with each project with some definite deadlines to meet. If suppose you are taking up with the project, then you have to finish up with the deadlines. That's the characterization. Next, cost includes the all sort of activities associated with the project till end. That means whatever the project you are taking up, all the cost incurred is calculated at the end. Then most importantly, each product is treated as project. When it comes to project kind of process, always remember the construction of say dams, maybe the shopping centers, maybe the buildings, maybe the bridges, right? Maybe the launching of satellite, all these types, or launching of the rockets, this kind of specific projects which may require the time deadline to be met, and it requires, most of the time it requires heavy investment, then they are considered to be the part of project process, right? Project tends to be complex. It is complex in nature. It needs long time to finish, and it consists of large number of complex activities. So many activities may be there in finishing up with one single project at a time. So it may require long time, right? It is made up of so many complex activities. Equipment flexibility and labor skill can range from low to high. That means whatever the equipments you use, or maybe the low to high, depending upon the type of project, whatever the project types may be, depending on that there can be the requirement of equipments, and it highly depends on that. When we characterize the project process, it is not produced in large number. If you are say using the example of construction of dam, then at a time 5 dams cannot be constructed. It is one by one that the project can be taken up. So in large number of production is not there. Projects have definite beginning and end time. It starts at a particular date and it has to end at particular time period, right? The requirement may not be uniform many times. It depends completely on what kind of development you need. Say generally infrastructural development and the projects are concerned or are correlated. So whatever the requirement may be there, depending upon that the project process may be taken up. Again, the resource allocation is very challenging, because at any time the resource may change. Manpower deployment is very difficult, as requirement varies and accordingly the changes are to be made. Manpower deployment means usage of manpower at different point of time of the project is very difficult, and that is why it keeps on changing from starting phase to the middle phase, or maybe to the ending phase of the project, right? Each cost of all the activities are interdependent, resulting many a times it results into excessive cost, because all interdependent costs and activities are there. The project process is taken at the production site. That means whatever suppose dam construction is there, that's the site, and if the project is taken up, or the production of this project process is taken up there, right? So every kind of resources that are required, they come to that place, and that is why it is static in nature. It is static production process wherein the resources which are required come around the product. That means for dam construction, if you need people, equipments, whatever raw materials, then at the site these things comes up, right? So it is static in nature. The controlling technique like PERT and CPM may be used. Program evaluation and review technique, you must have learned this technique somewhere in controlling, right? And CPM is critical path method. These are the two techniques, engineering techniques, which are used for controlling this kind of projects. When it comes to benefits, we can say that it helps to facilitate highly specialized projects, such as the projects are must for economic development. Few projects are such, say suppose infrastructural facility, you need to have the road construction, you may have the dam constructions done, and then at that time these kind of projects are coming up. So more the economic development, more would be the usage of these project processes. It helps to foster means to speed up the researches and innovations contributing to technological development. If there is much technological development in a country, then there are all chances that it may foster the researches, or maybe the innovations comes up very fast if the technological development is there in such kind of processes. Due to usage of the techniques like PERT and CPM, it can be effectively and efficiently controlled. Very important is this, that it has this specific thing that time is very important concern for the project, and the cost. Both these things can be controlled well with the help of PERT and CPM. So the more the controlling technique strongly that you are using, the project may give the definite results likewise. Major creation in the world are due to this process. Naturally, whatever the monuments, whatever the big projects that we get to see all over the world, it is due to this processes that it is possible to have the production of, or the say construction of such big things can be there. If we move to the disadvantages, it is complex planning. Naturally, so many things we are using, time is the major constraint, cost is the major constraint, or we have to keep this in mind, and that is why the planning is a little complex. It faces the uncertainties, so it results into excessive cost. At times when you start the project, you may feel that the labor requirement may be suppose 15 members, right? But when you reach the half of the process, you feel that more number of people may be required. Like this, there are so many uncertainties which may be faced, and that may result into excessive cost also at times. Many times the diluted performance may result into ineffective products. That means when the performances are such which means they are getting say a person is working at the site also, and he is working in the office also, the same person may not be able to give the performance, and at that time it may result into ineffective products. But that happens when the person or the team members are not equally allocated with the duties, right? Again, any delay in critical path, that means if the critical path is already longer, when that delays, or there is a delay in this critical path, it will result into the delay of the whole project. Coordination is difficult. So many activities, parallel activities are running, and if you can't coordinate the activities, it will turn up into a disaster then otherwise, right? Manpower planning in the construction project is uncertain and thus difficult to manage. Man is involved to greater extent in such kind of projects, and what happens because of that, if you can't have the manpower planning then properly, then it may result into many difficulties, right? You may have to face many management difficulties related to manpower there. And most importantly is, it is very challenging, because when you are taking up the projects, it is that the project is to be completed with the deadline, within the deadline. It is costly also, and at times it is having heavy investment into it. Already if you go with the excessive cost, it may be very difficult. There are uncertainties. You cannot have monotonous production there. It is not standardized. Each project is different from the other one, so you cannot even take the examples, or you cannot follow the modus operandi of one project and you can just imitate it. That is not possible, and that is why it is said that it is very challenging, right? Here so this is the disadvantage of say the project process. Here we are ending up with the project process as well as unit number 4, which was all about process selection. I think you all are managing with the notes. If not at all, then please do it. You may find it that in the text there are few points which may not be say, or whatever the points we are discussing in these lectures or sessions may not be available in the text. So I sincerely wish that you must have the jotted points with you, so that in case if the questions asked related to a particular concept, then you can answer it well with detailed say notes or points. So please jot down the points of each and every unit. So you must have at the end of the unit, you may have the whole summary before you, and you should be clear conceptually about each and every concept that we have used. So when we start with the next session, or when we meet in the next session, it will be the 5th unit that we shall start, that is related to aggregate planning, and we shall be doing with the same. By the time we meet next, it's a goodbye from my side. Take care of yourself, and we'll meet soon. Thank you.